All right, today we're diving into something that's happening on your network right now, but you probably never see it. It's called GratuitousARP. And trust me, it's one of the silent heroes that keeps everything running smoothly. Let's find out how it works.
So, let's just start with this kind of strange question. Think about it. Why would any device on a network just shout its identity to everyone without even being asked? It feels a little rude, right? Like someone just barging into a room and announcing their name. But here's the thing. In the networking world, this shout is not only polite, it's absolutely essential.
You see, at its heart, GratuitousARP, or GARP, as we'll call it, is all about being proactive. It's not waiting for a question, it's making a statement. It's a device's way of making sure every other device on the local network knows exactly who it is and where it is. This analogy nails it perfectly. Imagine you're the new device on the network. Instead of sitting quietly and waiting for someone to ask who you are, you just stand up and announce yourself. Hey everyone, I'm the new server, and you can find me at this IP address. It's a quick and efficient way to update everyone's mental map of the office, or in our case, their ARP cache.
And this is really all it's saying. Boiled down, the message is incredibly simple. A GARP packet is just a broadcast that says, hey network, just a heads up, this IP address now belongs to this specific piece of hardware, this MAC address. That's it. No fluff, just a powerful, direct statement.
Now, to really get why GARP is so special, we've got to put it side by side with its much more common cousin, the standard ARP request. They might look similar on the surface, but what they're trying to do is completely different. And here is the essential difference. A normal ARP, Address Resolution Protocol, is a question. It's your computer raising its hand and asking, hey, can anyone tell me the hardware address for the router's IP? I need to send it something. But GratuitousARP, it's the complete opposite. It's not a question, it's a declaration. It's a device standing up and saying, just so everyone's aware, I have this IP, and here's my hardware address. One's asking, the other's telling. That's the key. So let's just lock in that formal definition, so we're all on the same page. It is a broadcast message, so it goes out to everybody on the local network. And the key word is gratuitous, unsolicited, unprompted. The device is sending an ARP packet about itself without a single other device having to ask first. Okay, so we know what it is, but why does it even exist? Well, it turns out this simple little announcement has 4 incredibly important jobs that are fundamental to keeping our networks running smoothly. Let's break those down. So first, it's the official "Hello, I'm here" when a device powers on. Second, it's the critical update when a MAC address changes, like when a backup server takes over. Third, it acts as a quick check to make sure no other device is already using its IP address. And finally, number 4, it's the secret sauce behind things like high availability clusters, letting a virtual IP address hop from one machine to another without a hiccup. All right, we've talked about the what and the why. Now let's get our hands dirty and look at the how. We're going to tear apart a GARP packet and follow its journey across the network. This is where you can really see the elegance of the protocol. So let's imagine a classic scenario. You plug in a new computer, it boots up, gets an IP address assigned, let's say 192.168.1.10. The very first thing it wants to do is introduce itself to all of its new network neighbors. And the magic is right here inside the packet itself. Look at this. The Ethernet destination is all Fs. That's the broadcast address, which means this packet is going out to everyone. But here is the dead giveaway, the signature move of a GARP packet. The sender IP and the target IP are the exact same address. The device is essentially asking a question about its own identity. It's this unique, self-referential structure that tells everyone what's going on. So what happens when that packet goes out? Well, first, the host broadcasts it. Then, every other device on the local network sees it, and they react in one of 2 ways. If they have an old, stale entry for that IP address in their ARP cache, they immediately update it with the new hardware address. Or, if another device on the network is already using that IP, it sees the announcement and says, hey, that's my IP, and can send a reply to flag the conflict. It's a beautiful, self-correcting system. Now, for a more advanced scenario, let's say a critical server fails and a backup instantly takes over its IP address. Or maybe a virtual machine gets moved live from one physical server to another. In these cases, the IP address, the logical address, doesn't change, but the physical MAC address does. So how does the rest of the network find out about this change instantly? This right here is the payoff.
Look at this. Before the failover, every device on the network thinks that IP address belongs to the old MAC address. All traffic is heading there. But the second that new server comes online, it blasts out a GARP packet. Instantly, every other device on the network sees it and updates its ARP cache. The mapping is corrected, just like that, and traffic immediately starts flowing to the new hardware. This is how high availability and zero downtime failovers are even possible. It's all thanks to this simple announcement.
So, let's just zoom out for a second as we start to wrap this up. We've been deep in the weeds of packet structures, but the big picture here is what's really important. This isn't just some obscure technical detail, it's a foundational piece of modern networking.
So if you take one thing away from this, let it be this. GARP is the unsung hero of your local network. It's the silent, automated system that stops IP conflicts before they start, makes seamless failovers possible, and generally just keeps the network's address book clean and accurate, all without anyone having to lift a finger.
And that really leaves us with a final question to chew on. GratuitousARP is just one of these dozens of automated protocols chattering away in the background. It just makes you wonder, what other invisible conversations are happening on your network right this second just to make sure your email gets sent or this video keeps streaming? Pretty amazing when you think about it. Thanks for joining me for this explainer.